Okay, hello class. We are doing example 13 from page 86 in your textbook, and we're dealing with composite functions. Okay, so we're dealing with more than one function at once working together. All right, so here's the three functions that are defined in the question. These three functions are defined for us. F of x is equal to 3x minus 5, g of x is equal to x squared plus 2x subtract 1, and h of x is equal to negative 3. Now hopefully you would know what this graph would look like, if this function would look like as a graph. It's a straight line, so linear function, and hopefully you would also know what this guy would look like, also a straight line, but a special kind of straight line with no slope, so it's a horizontal line that crosses the y-axis at negative 3. All right, now we're asked to find, in number A, we're asked to find f of g of x. Now remember, when we are dealing with composite functions, we work with the innermost bracket first, which makes sense because in math we do that anyway. So f of g of x is what we say. That's actually equal to f of, well, let's replace this bracket with g of x. And g of x over here was x squared plus 2x subtract 1. So x squared plus 2x subtract 1. Okay, so now we're really just dealing with f of x squared plus 2x subtract 1. All right, we'd go to our f function. There it is there, 3x minus 5. Copy it down. 3x, instead put a bracket, minus 5. Where that bracket is, we have to pop in what we want the bracket to be, which is the x squared plus 2x subtract 1. And now we need to simplify. 3 needs to be distributed. 3x squared plus 6x, subtract 3, subtract 5. Combine our like terms, so 3x squared plus 6x, subtract 8. Okay, and there we have it. Notice that we put an expression into this function. The expression was x, and we got an expression out. Okay. Over here now, g of f of x. This is the same as saying g of f of x. These two notations mean the exact same thing. Two functions working together. Now, notice the opposite order from the first question, which was f of g of x. This is going to be g of f of x. All right, so replace the f of x with what the f function was, 3x minus 2. And then take the g function wherever there's an x, pop that x in. So that's 3x minus 5, 3x subtract 5. And remember, this means 3x subtract 5 multiplied by itself. There is a middle term there, so 9x squared minus 15x minus another 15x, so minus 30x plus 25. And here we get plus 6x minus 10 minus 1. Combine our like terms, so 9x squared, subtract 25x, and then plus 14. Okay, so that's that one. Now, let's go on to part C. Here we have part C. All right, f of h of x. F of h of x. So we look to our definition of what the f function in, there it is, f function is. And we look for our h function, those are the two we're working with. There's the h of x. Well, h of x is equal to negative 3. So this is the same as saying f of negative 3, which we already know how to do. Take the f function, wherever there was an x, make a bracket, put that number in there, and solve. So negative 9, subtract 5, negative 14. Okay, on to number D. F of g of negative 1. Now, we're putting a number in, so we should get a number out. So f of g of negative 1. So two ways you can do this. You can just start by, but you need to make sure you're notating really well. You can start by just defining g of negative 1 as being equal to, there's g, x squared plus 2x, subtract 1. Poke in the number, negative 1 in here. Find out what g of negative 1 is, which will just be this part. So 1, subtract 2, subtract 1, which is negative 2. Then, so this g of negative 1 is negative 2. So f of negative 2 is what we need to do next. And this is a good way to notate it if you want to do it this way. There we have it. And 3, oh, forgot to poke that in there. So that's negative 6. Subtract 5, which is negative 11. Okay, there's another way to do this as well. You get to choose. As long as you're using good notation, this is good notation, the way I did everything here. Or, if you want to do this all at the same time, with just continuing your equal sign down the side, we can say f of, and then we can actually do the g of negative 1 in here. X squared plus 2x, subtract 1, and that's where the negative 1 goes. And we can do that, f of, we're just doing this bracket here, so 1, subtract 2, subtract 1, which is f of negative 2, and then the rest is the same as before. It's 3, negative 2, negative 6, subtract 5, which is negative 11. Okay, so both of those are good ways to notate that. All right, on to part E. All right, part E says f of g of x. Okay, going to be a little more to this one. Let's move this up here. All right, so we need to do, we're putting an expression in, so we should get an expression at the end, whereas over here in part D, we put a number in, so we should get a number out. Okay, so put an expression in. Here we go. This is the same as saying f of g of x. There's that bracket belongs here, this bracket belongs to that g of x, and this bracket belongs to that f of g of x. Okay, so f of g of x, which is defined as x squared plus 2x, subtract 1. Okay, now we need to put this in the f function. The f function, 3x, subtract 5. So f of, and we're doing this part, 3x, subtract 5, and in there is where this goes. So, still not finished. This is going to be 3x squared plus 6x. Subtract 3, subtract 5, which is 3x squared plus 6x, subtract 8. Okay, not finished yet. We still need to put this in the f function. Okay, so again, the f function is 3x, subtract 5. In there we'll have 3x squared plus 6x, subtract 8. That's 9x squared plus 18x, subtract 24, subtract 5. And the final expression, 9x squared plus 8x, subtract 29. Okay, oops, you can't see that, can you? Just a sec, sorry about that. There we have it. Okay, I'm going to need to erase this so I can do the last question, which is question number F, f of g of h of 1. So numbers going in, so we should get a number out. I'll erase this part. And here we go. So f of g of h of 1. This is what we're doing. F of g, well, h of 1. H of 1. No matter what x is equal to for the h function, we get out negative 3. So that's going to be a negative 3. Okay, so f of then g of negative 3. Negative 3 in each of these places, which is f of 9, subtract 6, subtract 1, which is f of 2. Okay, we need to do that then. I would prefer if now you take an arrow and go up in that direction, but I don't have space on this whiteboard, so I'm going to go back here. All right, so f of 2, we need to look at the f function, which is 3x, subtract 5, put a 2 in there, so 6 minus 5, which is 1. Okay, number in, get a number out. Another point that's a good point to make is that back here in number A and B, we got two different answers. The number A was f of g of x, number B was g of f of x, and they end up being two different expressions from each other. One was 3x squared plus 6x subtract 8. The other one was 9x squared subtract 25x plus 14.